Alright, I just received my open sprinkler attachment for the Raspberry Pi in the mail today. I'm going to kind of do a little unboxing and we're going to assemble it in the new case. So this is the two items that I received is the expansion board that goes to the Pi and also the adapter. So this is looks like a 24 volt AC, 0.5 milliamp transformer. This is what's actually going to supply power to the sprinkler valves. This is a old Raspberry Pi that I was using for OpenHAB for some home automation. I ended up changing to a different software and I'm going to repurpose this piece of hardware. So that's there. Pull everything out of the box. We have looks like the top and bottom parts of the case, some screws, side pieces, spacers, extenders, power connectors, and whatnot. And we actually have the board. Let's see here. And that is all for this box. Here's the motherboard. Looks like they're doing a pretty good job of trying to protect all the connectors, all the pins. The header for the Pi attachment. Looks like we have a power input. Maybe looks like some pinouts if you wanted to put another board on top of this, extend it like a Pi hat or something. And then all the pinouts and pin inputs and outputs for your AC power input and your sprinklers. Just put that aside. And here's a connector they give you for the power supply so that you can connect it to the board and then plug into the transformer. Like we have more parts for the case. There's no instruction manual with this, so we're gonna have to kind of figure it out. I wish it came with an instruction manual, but it didn't. There is one online. You can always print it out if you want to. We're just gonna do this the old-fashioned way and figure it out. So we'll just kind of place all the connectors where they go. So make sure we have all our parts. Looks like we got some extenders here. I'm assuming extender is going to go in the board, stick through, or I'm sorry, through the case and then into the board. Here's some screws. I'll put those aside. That looks good. So let's open up the old Raspberry Pi. This is a case that I found online that fits a DIN rail. So inside a enclosure that's built into the wall, I have a DIN rail, and that rail is mounted sideways inside the wall in the enclosure. And then all these just clip on, and there's 3 on each side. So there's about 6 Raspberry Pis that do different functions within the house, from security to automation, lighting control, and also music. Hey, and that would be my German Shepherd, Kaiser, wanting to play. Stop. Stop. Alright, this is going to be interesting. Alright, so we'll start taking this apart. I found this case online. I think it was like $15 a piece. I think you could buy multiple of them. They're just, looks like they're just printed, or maybe plastic mold injection. But these work pretty good for holding the Raspberry Pi, protecting it, and keeping it inside a small enclosure. So this is a Raspberry Pi 3, I believe a Model B. It's got the one HDMI output, power input, 100 meg Ethernet. So I'm currently upgrading to the Raspberry Pi 4s for some applications because they're 1 gigabit that I need for extra traffic. Example one for my Christmas lighting display is technology grows, we add more lights, there's more data coming out of it. As they try to work on compression, there's this battle between compression and Ethernet data usage. So I went in and upgraded, plus you get more memory and more speed. So that's that. Again, that was, I believe, about $40, but I repurposed it. So let's go into the case. Sorry about that. Dog's flinging his toy around, getting a little crazy. One down. Now I'm guessing they probably put this material on here to, while cutting it. Can't tell if it's cut with a laser or like an end mill, but I'm guessing they put this material on here to keep the plastic from getting scratched or damaged while being cut. Not the easiest thing in the world to take off, but could be worse. So, all right, 2 pieces, and they are extremely hard to see in this white background being clear. Put them on a box so I don't misplace these. So this is just to recap as I'm going over this. This is a open sprinkler project. Works off a Raspberry Pi, and the goal of this is to be able to run your sprinkler system from a Raspberry Pi without spending tons of money. So this project, I think total cost over time, if I were to buy all the parts new right now, would probably be maybe $70, maybe $80 total. And that would replace the controller that you have today. The thing I like about it is it is open source. It does allow you to add other inputs into this. Using the software, you can pull in weather. You can make predictions based on weather, whether or not to, no pun intended, to water. Also, what's cool about it, you can even put a moisture sensor on here, and it'll allow you not to water if there's moisture in the ground. I'm sure you could add maybe like a level sensor, water level sensor or something, see how long it evaporates if you wanted to get that far into it. But just a cool little project. Got a nice little website to it. Apparently you can also, they have an app for it on your phone, and using the company's external server in the cloud, you can access this remotely, and I think there's also a way that you can access via your internal network. From what it looks like, it does not look like the website's encrypted. So if you do this, obviously you would want to do some sort of tunneling. I don't know if I would recommend putting this out on the quote, the internets, just to do security. What I do like about it is I can integrate this with HomeSeer, which is now what I'm using for my home automation server. So it's going to be like the central hub. So all my lighting applications, all my security, the security system, it all reports into HomeSeer. Each of the systems can operate independently. Also, I can create rules on one common server to make buttons to do multiple things at once. So what's cool about this is if the alarm is triggered, it's going to report to HomeSeer. HomeSeer, you can actually make rules of what to do based on that input. So for instance, someone opens the gate in your backyard at the middle of the night, HomeSeer can tell it to turn on the lights and the sprinklers. Give them a little scare from the lights of whoever's on your property, and just to be an ass, you can turn on your lights, and then just to be funny, you can soak them with water for being in your backyard. So that is one advantage. Also with HomeSeer, there's apps where you can log when it turns on and off. And OpenSprinkler they do have a module for HomeSeer, what they call a plugin. It is free, so there's no cost to integrate OpenSprinkler software into HomeSeer, which is nice. So that was one of the decisions I made to go into the OpenSeer or the OpenSprinkler project. Since I had HomeSeer, they were integrated for free, so that was nice. There are other sprinklers, controllers that you can buy out there for a couple $100 that are Wi-Fi. They come with a cool app. Select all your zones. What was cool about this was it's open source, it's fun, it's a Raspberry Pi, it's a good project. It's expandable, so you can add on modules to this. So right now it comes with 8 zones. You can add, I think it's like $30 for an extension module, and then you can add another 8 zones to it. You can actually connect multiple modules together. You can have separate modules, Raspberry Pi modules, and you can integrate them all together if you want, and have one control, like one primary module controlling the rest of them, which is pretty cool. You could use this in a small house to a large house with 8, 10, 16, 32 zones, to a church. Say you want to save money, you don't want to spend hundreds of dollars on a controller. Nonprofits, church, farms. This would be great, on a farm or like a greenhouse. Want to save money, but something you can integrate later. And being on the Raspberry Pi, you can add other inputs. I think there is some challenges with one wire. I was reading that it uses a pin for one wire, but I think there's more one wire pin inputs on the Raspberry Pi. So you could probably use one wire for humidity and temperature on another port. So that's one of the things that I'm going to be looking into, either on this or maybe integrating with HomeSeer to say if the temperature is above this value or humidity, do not run. Put it in the disabled mode. That way it doesn't go enabled. Same thing, you can create events, like if they're going to mow your lawn on a Saturday morning at 7 or 8 a.m. Don't run the sprinklers in the morning. So when they come through and mow your lawn, they're putting ruts in your lawn. So really cool on the software part. Good integration. I have not used it. This is the first time. I've just installed the application on the Raspberry Pi. I have not tested it in the hardware, but it should be very simple. I believe it's just using solid state relays here to control the valves. And technically, you really didn't even have to use this module. You could probably written your own code and just bought like an 8-port relay for $20 and attached it to the pin output on here and had no problem whatsoever. I mean, you could have done it that way if you really wanted to go open source. I wanted to use the module, you know, a hardware that's been tried and true and tested. That way, if something goes bad, you know, I just know I got to order another one of these parts and I'm done. And I don't have to worry about finding something that may have been discontinued and having to worry about integrated a different way or different pinouts or wiring. So that was kind of my choice on this one. All right, so here's the Pi, and it looks like we're just going to match the pins up, place it in there, and looking at it, it looks like you can see there's a gap over here, so I'm guessing that we need to put some extensions in between. Take this back off. Really wish there was an instruction manual with it. Let's kind of work our way backwards. See if we can put together this case. Can't see that because it's clear. I'll try to put it on here, maybe that'd be a little bit better. It looks like this is the case, and Pi's gonna sit in here. Doesn't look like there's any mounting holes on it. Here's the top. Mounting holes don't match up to the Pi. Looks like it's going to go this direction. These are going to have to come out because there's holes in the side of the case. Same thing, there's one here, and this piece doesn't match up. So flip it around right there. Take that off. It looks like all those pins match up, and just kind of lay these down on the outside. Those holes line up. So now the question is, the Raspberry Pi is going to go on here. There's no holes that go through here. So looks like this is the right height. I guess these guys are just going to thread into the motherboard or into the expansion card here. This hole's a little smaller. Well, I don't know if that's the best way of doing it. I don't see any extensions except for these little short ones with screw holes on both sides. Let's see if this matches up really well. It's a little bit high. If we were to put these on, you know, looking at it, I think it's going to use these. I'll take this back apart. Little screws here. Kind of a tight fit in the motherboard here. Ooh, I don't know, I don't like that feel. Let's see, might be using the wrong thread size here. Looks like there's a smaller screw. Let's see if it fits in this extension. Nope, it does not. So we're gonna have to use this larger thread. Just have to be careful and thread it in. So it's gonna damage anything on the motherboard. All right, that's in there. Let's take one of these, thread that in. All right, let's put this back on. Just make sure everything lines up and it sits at the right height. That looks much better. It's definitely, it's a little bit lower. I don't think. Is there a third? Oh god, there's a third one. So there's 3 different sizes. So short, medium, tall here. So looking at this, this is the shortest one. The board flexes down. We probably don't want that. And let's just do a quick count. So there's 2 of these small ones, 2 medium, oh, another small one, 2 tall, and 1 here small. So I'm guessing these 4 go on the outside because there's 4 holes on the outside. The board has 2 to hold it to the Raspberry Pi, and then we'll have to figure out where these 2 go here. So this is troubleshooting, guys. Dividing and conquer, divide and conquer. We learn. So you don't always need instructions, but it is nice if you want to only do it once. So let's take this back off. We have our 4 there. You gotta be kidding me. 2 different sizes on each side or something? Won't thread in there. There we go. Now I'm going to have to use something to hold on to it because my fingers can't grip it. So be very careful. And thread that in there. All right, 1 down. All right, screw. Same thing, the other hole's definitely a tight fit. Just kind of thread it in. Let's get it started. Alright, well, it looks like the battery ran out on the phone as I was putting this together. So I'll kind of give you an overview and work a little bit backwards on what I ran into. So this is the finished product. Top plate, side plates, all the plugs are in there, and the bottom plate. As you can see, I'm missing 2 screws on the bottom, 2 screws on the top. Also, the screws on the top don't tighten down. They get a little snug, but like this one just spins. That one's totally threaded, stripped threads, and it almost looks like the screw's not even. It's a little bit too small for that extension. So, funny enough, the screws on the bottom fit nice and tight. Those are fine. It's just the screws on the top. So a little disappointed on the size of the screws with the top extensions. I did run into an issue where, while putting it together, figured out that there's a white plastic extension here on the bottom that goes in. Screw attaches it to the bottom of the case. Then you put the motherboard on. You attach all of the longer extensions, which I'm going to call the long, and this is going to be the short. There's 4 of each. You attach this top extension that's got a male thread to go into the female part of the extension. Tighten all 4 of those down to hold the motherboard onto the lower extension onto the base plate. Once that happens, you can then put all your side plates on. It's a little difficult because you have to hold the corners. You kind of have to hold it like this and then put a screw in, because if you don't, if this comes off, the side pieces just fall out. After you're done, you're going to put on all your connectors. Make sure that you have your memory card installed prior to putting the top on, because there is no slot to remove the memory card. Other than that, for the cost of the acrylic and the extension board, I think it's a pretty good purchase so far. I just wish they give you the right amount of screws, since as you can see I am 4 screws short. So I'm going to replace those on my own. We're talking about maybe $1, $2. Honestly, I'm just going to look in my box full of spare screws, and I'm sure I have something that'll work. So that's no big deal there. There were no screws to mount it to whatever fixture you're going to, but again, that's no big deal. If you're going to go into wood, you need a wood screw, metal screw, maybe a hole with, screw and a nut. So that's not really a big deal. Just something you have to be aware of when you buy the kit. You're going to need something to mount it to it. I mean, you could just put sticky tape on this and stick it to an enclosure, or use Velcro on the bottom. Attach it, and if you ever need to remove it, you just undo the Velcro, put it back on. But this is the final product. Here is your connector. Wires go in here. It's AC, polarity should not matter. Check the manual just in case. There's a wiring spec if they want a particular color, positive or negative on a different side, just for standards. And then here's your 24 volt transformer going from 120 volts down to 24 volts AC. So this is what's going to plug into here. Just plug into this outlet, and then all your sprinklers have to be 24 volts AC. From my understanding, I think you can use DC with this board. I'm not 100% sure, but for this case, it did. They come with a 24 volt AC power supply, which is most common for the sprinkler valves out there today. Oh, the other thing I would want to mention, there was 2 other screws that are extremely way too small. These did not fit in anything. I'm not sure where these go or what they would even fit into, because they're way too small. So again, my only challenges with this is the screws to hold all the case together. But other than that, pretty good purchase. Software is good, and when we get this installed, I'll do a video later on wiring up the valves, and we'll do some more hardware testing. So if you have any comments, put them below. Thanks for watching.